Well, hello SINUMERIK Nation, and welcome to another episode of Simply SINUMERIK Live. I'm your host, Chris Pollock, and today we're going to be taking a look at the EMUGE Thriller. So what is the Thriller? Well, the Thriller is a pretty unique little tool. What it allows me to do is it allows me to combine 3 different operations into one. So I can drill my pilot hole, I can thread, in this case my 1/4-20 thread, and I can chamfer all in the same tool. So kind of what led me down this road to explore this tool? Well, for me, it was really all about capacity. So I got a great little fryer machine here. Works perfect in the studio environment. However, with the emphasis on little, my tool changer is on the smaller side. So I am limited to 10 tools in my ATC. So with that, I have to get pretty creative. Now, another area where you might run into a similar kind of scenario is in lathes, right? A lot of times when we get to lathes, we are limited in our turret capacity, so you get kind of creative there. But, you know, I don't really care who you are and what size machine you're in front of. It seems like no matter how big that tool changer is, you always seem to run it right to capacity and need to get a little bit creative. So, with that, it leads perfectly into this tool. If I could take 3 operations and bring them down to run, now I just freed up a couple pockets. So that's what kind of led me down this road of the Thriller. Now the other reason I wanted to explore it is we've had a CAN cycle in this system, in the SINUMERIK control, that supports this tool for quite some time. And I never had an opportunity to run it, and I was always curious how well it worked. So kind of all things aligned, my planets aligned, and it was a perfect opportunity. Now in this case, I've been working on this little part. We've been using this a few different times over some demonstrations. It's a little kind of cog style gear. So I wanted to come in and I wanted to drill and tap or thread 1/4-20 for my belt guide. Now if we look at the tool, we can give you a little bit better view of what it looks like. It's pretty interesting. So it looks like a traditional thread mill. However, it has a 140-degree tip angle at the tip that's going to drill out to what your nominal tap drill size would be. So in this case, it's going to drill to a 209. And then from there, I'm going to have the thread mill section that's going to allow me to mill in the thread. Now in this case, I can take it actually all in one cut. So it allowed me to really get right to depth, drill it, and then that top section is actually ground specific to this geometry and spec of tool to give me the appropriate chamfer on the top of it. Now there's a range of tools you see on the right in the full combination of drill thread mill. However, you are limited to a specific depth, right? So in my case, I was doing a pretty shallow hole. So 1.5 times D was perfect for my application. They do go all the way up to 2.5 times D, but you do have to work within that range. Now outside of that, EMUGE does have some other Thriller series that will just handle the drilling and the threading of the physical hole. So it does take out the chamfering of it. Maybe we'll take a look at that tool in a later video. But right now we're going to kind of concentrate on this combination tool. So with that, I say we go right into seeing it in action, and then we can play around and show you guys a little bit of how I programmed it, how I handled it. So I have our machine set up. We got a blank in here. Now in my case, since I've been kind of machining these parts in batches over a little bit of time, my 0 section isn't necessarily perfectly in the middle of my part. So I did incorporate a quick little in-process probing routine to find the top of the part, find the center of the part to make sure that this feature would be dead center of this gear profile or this cog. Now here I'm using the built-in cycles within the control to handle my measuring, and then I'm rewriting the work offset. So if I was to look at the work coordinate, take a quick peek, and I looked at my fine, this is where I'm adjusting it based on my initial 0 set. So now we're going to come in. Now when we first come in and drill, you do want to do a couple pecks. I'll be honest, when I first started playing with the tool, I didn't do any peck, and it did really well. I think if you want to run it more at the the designed feed rate of this tool, you do want to make sure you've cleared that. So I got a couple quick pecks just to pull out any chips out of the hole, but you notice I'm immediately staying in the hole and then I'm dropping into my thread milling routine. So I'm down already at the effective diameter. When I hit the max depth is also when I chamfered. And now we're helicing and terping one shot, one cut, brings it right to size. So what's nice is every time I pull that tool out of the hole, I have a completed operation. I don't have to come back in and do anything else with that tool. Now, when it comes to using the tool, it is designed specifically for non-ferrous materials. I'm obviously running it in aluminum or cast iron. If you do need to explore other materials, steels, alloys, you will want to take a look at maybe one of the other Thriller products that they have. So if I come in, take a quick little look, blow off some of my coolant, we now have our threaded holes. Now when I came in and gauged it, I didn't run out and get a fancy go no go. I just used the old bolt trick, but brought it right into size here. Okay, so pretty neat, super fast. I actually ran this from the drilling size at probably half the feed rate that was initially recommended. Certainly I could have pushed it a little harder. I was trying to limit my coolant so you guys could see what's going on. So sometimes I will run things a little bit slower depending on the footage I'm trying to capture. Okay, so let's dig into the tool a little bit more. We'll show you how I programmed it, and we'll show you a couple other alternates. So in my case, I'm using a SINUMERIK control. So I do have the ability of using that built-in can cycle. However, if you don't have a SINUMERIK control, or maybe you're just not too sure about that cycle, we can do this traditionally. So we're going to do it two ways. I will also run a second part where I'll just use it as a standard drilling cycle, and then I'll come back in and thread mill. So we'll talk about that a little further. But for my program, and let me give you a nice close-up of the control, we can start to see how I built it. Now I did do it inside of G-code. So this is our program guide interface. So it's G-code with conversational cycle support, you'll see. Certainly I could have done this completely conversationally in shop mill. We have full support for all the cycles you're seeing inside a shop mill as well. So in the beginning, as I mentioned, I did want to do a little in-process probing. So I loaded my probe up and I jumped into my built-in can cycles. Now you do have to have the option for in-process probing, but once you do have it, now I can do things like position my tool, come down, set the top of my workpiece. So here I'm writing my workpiece in a Z direction, setting that top to be 0. I also took advantage of another cycle we have, which is finding the middle of my bore or a feature and then setting a 0 there. Now all of those cycles can be found in the SINUMERIK control if you expand over and use the measuring workpiece soft key, and then you'll see you have a whole array of different cycles. So if you don't see that soft key on your system and you happen to be on a SINUMERIK, then you probably don't have the option, but certainly could always be added. Okay, but that's not why we're here. We're here to explore the Thriller. So, if you notice, first thing I do is I do my tool change and I loaded up my drill thread mill, and is what I named it, right? You can see it right here on that line. So when I create the tool, I am going to build that tool from a tool that's already inside of my tool library. So if we go back to the offset table, you can see the tool in my spindle, the tool is still physically in the spindle, is the drill thread mill. So you can find this tool right inside the library when I build a new tool, under cutters. Get that? There's your drill thread mill cutter. So it would be a little different than setting it up as a physical thread mill. So when you look at it from an information standpoint, I really only need to know my gauge length. So I've set up my machine for positive tool lengths. So that means that I'm compensating from my gauge line. In this case, I just set up the spindle face to the tip. So I do need to know that. That I measured off my probe, my Marpos probe. And then I do need to know the effective diameter of the thread mill as I interpolate that. Now this information was given to me by EMUGE. So EMUGE has a wealth of knowledge in their tech department. So if you have any questions on this application or any applications, give them a call. They'll set you up with the proper speeds and feeds, techniques for actually applying the technology. In fact, they even have a method to create a standard ISO program for you. So in my case, I had all the functionality in the control, but if you don't be afraid to give them a call. They can help you create the program and apply it to your specific machine. So in here, right off the bat, I did need to know what the tool diameter was. So they gave me the tool diameter at 191. Now, if you had noticed, I did a little bit of a tweak. I actually adjusted about 2 thou. That was me just gauging in the part. So from that side, it could have been my machine was interpolating a little under. Certainly, I could have made the adjustment in either the major diameter of the thread, the max diameter. Mine is set to 250, or I can adjust it right in the diameter. I chose to do it in the diameter. Later, I'm going to need to know where the optimal depth of running that tool is going to be so I can chamfer that feature. So that's going to be given me in the IE dimension. So we'll jump back to that. Now, when I continue looking at the program, I'm now going to come in, fire up my speeds and feeds. My spindle speed was given to me by EMUGE. That's a 330 surface feet. So that was what it would come out to, my 6,000 RPM and change. I did do a quick little pre-position just to get the tool kind of close to the part, fire up my coolant, a lot of the normal stuff I would do in G-code. And then we go into our can cycle. So in the SINUMERIK control, if you go under drilling and then under thread, you will find we got a couple. We got our tapping cycle here, and there's a whole host of different tapping configurations. But you also have the drill thread milling. So this is that standard cycle in the control that supports this tool. So we had created this cycle in conjunction with EMUGE back in Germany. From what I was told, while they were designing the tool, we were working directly with them to kind of create this feature, this function. So in my example, my quarter 20, I have it pre-created. I'll open up the cycle. This is what I mean by our conversational support. So I'm in a G-code program, but you still open up all the can cycles conversationally. So it's kind of like a hybrid. So a couple things I needed to know. First thing, obviously I set up my basic, where do I retract to? How close do I get to the part when I start cutting? My pattern modal, it's because I'm going to have multiple holes to do. But what's nice with the can cycle, again, as you saw, it's going to give me a completed physical hole with all the threading and the chamfer all in one shot before it moves to the next hole. So I'm really limiting the number of rapid moves I have to do. Now on my part, my feature was down 1/4 of an inch, right? Because I have that little boss that sticks up on my part. So I made my effective top of the part 250. Now my feed rate was 25. This tool you can run right up to actually 50 inches a minute. Again, I cut it down a little bit just because I didn't want to crank the coolant too high, or you guys wouldn't have seen anything on this application. But I did run it at that feed, and yes, it will absolutely run at that feed rate, which was cruising if you ask me. Okay, now this is where that critical depth comes in, the 472. Now I chose to program it incrementally because it's 472 off of the 250 shift, right? Because I moved the top of my feature down. I could have set an absolute. I would have then just had to add those two numbers together. It's really up to you. I could change it. But that number is what was given to me directly from the EMUGE documentation. So when I looked in, I could see the IE dimension is going to put me at the appropriate portion of the chamfer for a 1.5 times D hole depth, giving me the right chamfer size to break that chamfer. You could go a little deeper. There's plenty of additional angle, but that's going to give you the optimal chamfer or corner break for that style of hole. So that's where I got this number from. My PEC, I played around with it here. I took 300 thou as my first in feed off of the -250, right? So I'm already well into the part. Then I did one retract, and then later I did a secondary retract at the bottom. I can, just like our standard drilling cycles, maybe decrement my PEC if I wanted to. It's not a very deep hole, certainly not on a 1.5 times D, so I didn't really need to. We do have a couple extra provisions, but I was able to go right down into the lower section of the cycle, and that's where I handle the thread milling. So this bottom option, yes or no, is going to give me a final retract at the very bottom of the hole. So that'll ensure that I clear whatever chips could be down there from the drilling op before I go in and start milling. Just keeps me from recutting those chips. So I did choose to do a final chip removal, even though I was pecking it early. I probably could have certainly gotten away with maybe no peck and just did the one at the very bottom. Certainly would have been probably fine as well. Pick your type of thread. It's a right-hand thread, so I had to choose right hand, obviously. Then you choose the feed rate. So the feed rate was given to me. That was given to me directly from EMUGE. So what we were spec'd at was, from a thread milling perspective, it was 3 thou per tooth. So effectively at the center of the cutter, I'm going to be running 10 inches a minute, because at the edge of the cutter, and especially if you were with me for one of the previous thread milling examples, the actual cutter edge is going a lot faster, right? Now, in our thread milling cycle, we do some auto calculations for you. In this cycle, we do not. So you're going to have to program the feed rate as the center of the cutter, and you'll have to do that calculation based on your part size and, more importantly, your tool size, right? So I plug in my 10 inches there. And what was nice is that was given to me right off of the spec sheet that EMUGE provided. So you can see on that right image, there's a center line feed of 10 and a cutter edge feed of 40. So that was where I got my 10. Certainly I cross-referenced it to my own calculator just to verify that those numbers were what I expected, and for sure they were. I told it my thread geometry, gave it a little bit of a retract about how much I want to pull back before I start threading, because you're not going to thread right at the very bottom of the depth of this hole. There does have to be a little bit of an overrun to accommodate the front lead of that drill. Same thing as if I was tapping, right? I have to compensate for the lead of the tap. So that's pretty common, but I think you can get this a lot closer than you traditionally would even with a bottom tap. And we give it our major diameter, and then I decide how I want to machine it. So down cut or up cut strategy, or I could do both. So I chose a down cut strategy. Once I filled it out, I saved it. I linked it, because it's modal now with the M-call, to our onboard bolt hole pattern. However, I could have certainly made this just rapid moves had this not been a bolt hole pattern. We have a whole series of position cycles available to me, or you can just do basic rapids like you normally would in G-code. And that was it. So once I got it all kind of worked out, I was able to go into simulation, take a quick look, and then I could kind of tweak my strategy before I certainly cut my first part. So there you see my little probing feature, and now I come down. Now in my case, I didn't want to drill and leave the boss, so I just made my blank for my simulation a little bit larger, and it's actually shifted 250 down. So if I was to look at like a side view, so this surface, my zero is up top, if you can see that scale. This way I could kind of just prove out the drilling routine. Had I was making this part from full roughing, then I could have the stock and it would have shown the boss and everything in there. Okay, so we see our holes. If I zoom in, and we'll just tip her down, there's my nice little multi-touch display. But you can see you got a nice little helix at the bottom of that. Let me zoom in just a little bit more. There you go. So we come in, we drill, and then while at depth, back up just that little bit, that 60 thou that we told it, and then we helically mill it. All right. Now, what if you don't want to use the cycle? What if you don't have that cycle? So for sure, I can also do this kind of longhand. So I can jump in and I can break up my operations. So in this case, everything in the beginning of the program was the same. But now, once I loaded the tool, I came in and did a traditional just drilling cycle, our cycle 83, which is my peck drilling cycle. Still had to use that same critical information, right? I needed to know the depth so I could chamfer it. I'm not going to go back and chamfer it after it. I can do it all in one shot, which is really nice. So I went and drilled all the holes with my little bolt hole cycle routine. There's my bolt hole routine. And then I came back and I did our traditional thread milling cycle. So in here, this is that throwback to what I was saying about our traditional thread milling. In the cycle, we're expecting you to actually give me the feed rate at the cutter edge, which is the 40, and then we'll do the calculation for you. So that's going to back calculate to the 10, driving the tool from the middle of the tool as far as feed rate. In the drill thread mill cycle, you don't have to do that. You can just tell it the center line feed rate. So when we run it, you'll notice that it's actually running at 10, even though I programmed 40. But other than that, this is pretty standard to how I would have treated any normal thread mill. So if you look down at the geometry, gave it my top of my part, my depth, my major diameter. Here, if I wanted to, I could have done a rough and then a finish. Honestly, you do not need it with this tool. Bringing it right to side is going to get you there. So if we want to see what this program would look like and kind of just see the difference, I can load up a second part. We have a few blanks and we can run this one. Okay, let me blow off. So I'm going to do the same routine. Obviously, I'm going to come down and let it find the center, and we're going to drill. Once we've drilled everything, then we'll go back and we'll thread mill. Now again, if you don't have all these can cycles like we have in our library, then absolutely reach out to EMUGE and let EMUGE kind of build you up a basic part program so you can still use this tool no matter what control that you're running on. But for me, I would certainly rather hear you run it on a SINUMERIK control. All right, so there's our quick little measurement. We will do a little Q&A at the end if you guys have any questions. I'll also put the programs on the site for download in case you're interested to take a look. So here you notice I'm coming in. I'm doing the drilling operation first. Now when we drop in and do the feed, take a look at the feed rate. I'll go to our other shot so you can see the whole thing. So you see it calculated just under the 10 inch per minute. So that's based on a 40 inch per minute programmed feed. So that's where our standard threading cycle does a little bit of math calculation for you. The drill thread mill cycle does not. All right. Very, very, very cool tool. Had a lot of fun playing with it. Definitely going to want to explore more in this family. All right. Well, I'm not seeing any questions. It looks like you guys are somewhat quiet today. If there are any questions, pop them in. If not, then certainly thank you for joining. As always, if this content is of value to you, hopefully it is, please remember to like the videos, absolutely share the videos, and subscribe to the channel so you're going to get your notifications. Am I using a cutting edge to set each spot on the tool? So I'm only using one cutting edge. I did not have to use multiple cutting edges. I'm assuming you're talking about when I bounced between thread milling. So I was able to still work off the same singular cutting edge. So just one cutting edge. All right. So as I said, I'll grab these programs, put a link so you can download them if you're curious to take a look at it. But again, check it out. Very cool tool. Certainly worth exploring. I would say it's going to help you not only from a capacity standpoint, but having played with it, if you have our cycle, or you use a longhand cycle, to be able to finish that hole before you move to the next one. And the 5-part event, I did to check the cycle times between the two operations. It was only a few seconds, but we're alleviating half of the rapid moves by staying in that hole. So if you have a lot of holes to do, I could definitely see this helping you from a cycle time perspective. Okay, so with that, again, thanks again for joining. I have a lot of fun doing these, so hopefully you guys are enjoying them as well. So like, share, subscribe, and I will be at East Tech next week and at Automate the following week. So if you happen to be there, stop by our booth. We are in both booths, or we have booths in both shows, shall I say. Come by, say hi. I'd love to get a chance to meet you. And with that, thanks again, and I look forward to seeing you guys real soon. All right, take it easy.